everybody. So today I am going to explain you about the experimental setup of this whirling speed of shaft apparatus. Okay. So here you can see this experimental setup of this whirling speed of shaft. Okay. So here a long shaft of diameter 5 mm is fixed in these bearings. Okay. And here this support we are taking as a fixed support, and this one is the free end of the support. Okay. So here what we will do is, so first we have to understand what is meant by whirling speed of shaft. Okay. So whirling speed of shaft is the speed at which the deflection of this shaft is maximum. So when the deflection of this shaft is maximum, okay, so then that speed, so the speed at which the deflection of the shaft is maximum will come at maximum, and after this speed, so the speed again, the deflection of the shaft again decreases, okay, from the maximum position to the minimum position. So after this critical speed, so this critical speed or whirling speed of the shaft is the speed at which the maximum deflection of the shaft occurs. Okay, and beyond this critical speed or whirling speed of the shaft, so again the speed going to decrease. Okay, so this is simply about this just a overview of what is meant by whirling speed of the shaft. Okay, and now let us just measure the diameter of this whirling speed of the diameter of the shaft. Okay. So here I measure this diameter of the shaft by means of the vernier calipers. Okay. So I hope all of you know this vernier calipers. So it is 5 mm is the diameter of this shaft. Okay, so the diameter of this shaft measured by this vernier calipers is 5 millimeters. Okay, and also this length of the shaft is already measured with the help of this measuring tape. Okay, and the length of this shaft is 0.9 meter. Okay, so and coming to the density of this shaft material, so that is 8000 kg per meter cube. Okay, and the material of this shaft is steel, okay, stainless steel. Okay, so that is approximately having 201 GPa is the Young's modulus of this material of the shaft. Okay, so now what we will do is to find the critical speed of this shaft. Okay, so we will rotate the shaft. So here is a variable speed motor, that is a, okay, so we switch on the power supply here. Okay, when we switch on the power supply, this the power comes to this thermostat, okay, the variable speed motor or thermostat. So and then when we increase the speed gradually, okay, so the speed is going to increase, and we will be going to see the speed in this. We are going to see the speed in this display. Okay, the speed in RPM in display, so that gives us the critical speed. So at the point where we match the deflection of the shaft to be there, so we are considering only first mode. Okay, so first mode in the sense that so only one sinusoidal half sine wave will come. So where the maximum amplitude of the shaft is there, so at that point we will take the reading of this critical speed in RPM in the display. Okay, so this is our just overview of the experiment. So we will, after noting down the reading of this critical speed, so we will do we will tabulate the readings and make the calculation part, that is which is necessary at the end of this experiment. Okay. So this is the about the overview of this question. So this is the fixed end. So this is the free end. Okay. So you have a 0.9 meter long shaft. So the diameter is 5 mm. As I already told, the density of this one is 8000 kg per meter cube, and the material is the steel material. Okay. So now here I will just start the experiment. Already this shaft is already fixed, okay, in the required bearing supports. Okay. So now I switch on the power supply. Okay. So just slowly and try to increase the speed and see at which the maximum deflection is coming. So I will, after reaching the maximum deflection, I try to increase the speed further. So if I increase the speed further, if the deflection is decreasing, so then at that point where the deflection is decreasing, where the amplitude of the shaft or deflection of the shaft is decreasing, so that point we note as the critical speed of the shaft, and that the corresponding speed we will note down here in the display. Okay. So now I will start this variable speed motor slowly. I will gradually increase the speed. Note the corresponding speed. So at that point we have to note the corresponding speed. So just to show you how it can be done, just I have shown with your trial. So now we will note down the actual reading. So now you can observe, so outside wave is coming, actual amplitude is coming. So again, try to increase further. So now in the calculation part we will find out the deflection as well as the critical speed in edges, cycles per second. Okay, so for the first mode only we will conduct the critical speed. We try to find the critical speed of the shaft. Okay, so now we have found out by the experiment. So we will go to the tabular form and calculation part. Okay, in the coming time.